Hello ladies and gentlemen, today we're going to talk about Boxplot, but there's a couple things we want to review a little bit or just clarify a little bit. So let's start. The first thing we want to make sure that you guys understand unimodal. We kind of went through those couple words, but we never really come down and define them. So unimodal is has one mount, and bimodal has two mounts. Multimodal has more than two mounts. Really, in other words, is peak. One peak, two peak, or more than two peak. So that's pretty much it. Okay. So in this case, if it's unimodal, it should look like this, and then bi should have two humps, and then if you have more than two, that will look something like that. Could be more. Okay, so in that case, when we talk about a box plot, we are talking about only one. So it's very important they clarify with you guys that says when they want you to construct a box plot, and they explain or they said it in the instruction that this is a unimodal. Whistler's IQ test measure a person's intelligence. A density histogram of IQ in points of some people is displayed in figure 65. Some of the bars have been left blank on purpose. Okay, so if that's left blank on purpose, then we are not going to worry about it. So first of all, the IQ score, and the very first thing they want you to find is median. The big M stands for medium, so we're going to take a look what is the middle 50 percentile. And if it's in the middle 50 percentile, the point is at 100, right here, because they both are even. Okay, then estimate the average, which is the mean. The next thing is the mean. Now the mean is also 100. The reason for that is because that the center is also both sides balanced. So when you average it out, it's going to be also at 100. And if you take a look for number 3, estimate the standard deviation. Now that's a little tricky. You kind of go, where should I look for? Okay, I don't have number to calculate. So let's take a look at the numbers they give you. Well, the number they give you between here to here, that is 0.34 and 0.34. Hey, that is 68%. And because that's a 68%, that means that's a first standard deviation with a cut in the middle that is going to be halfway. Now halfway, that tells you the 100 is the mean right here. That's your mean. And if that's your mean, this is 34%, 34%, and 34%. And that's going to be your 68%. So therefore, that is your first standard deviation. It's when you take the mean 100 plus what give you 115. Well, if you do 115 minus 100, you actually have 15. So therefore, your standard deviation is going to be 15. Okay, now you double check. 100 plus 15 is 115, plus another 15 is going to be 130. Example 1. Students in one of the Arthur statistics classes are surveyed about the number of hours they study per week for the course. Here are the anonymous response in hours of 10 of the students. Okay, those are the hours they studied. Okay, I'm not going to read them out. Which is better measure of the center, the mean, or the median? So if you take a look at the data and then you do a quick histogram sketches on your calculator, you will notice this data is skewed to the right. Now because it's skewed, it will be better if I use a median as measure of center. So because of skew actually because of the distribution is skewed. The medium is a better measure of the center. Okay, now how do we do this by hand? Just in case you don't have a calculator. Well, you first of all, you need to put all your numbers in order. So if you take a look at the number that's in order, that's going to be 2 is the smallest, and then you have 3, and you have 4, and 4, and you have 5, and you have 6, 7, 10, and 17, and 28. So because you put them in order, one, you can do it by hand, or you can do your Q1, Q2, Q3 by calculator. It's up to you. Okay? And then we're also going to be using that a little bit later. So it's very important you know how to put them in order, just from the smallest to the biggest. Now, number 2, it says Q2 is same as what? Well, I told you guys previously, it is same thing as medium. It's also at the 50% area, okay? And Q1 is, in this case, if you in your calculator, you can figure out that's 4. Or if you do it by hand, you have 1, 2, 3, 4, 4, 5, 6, 7, 10, 17, 28. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pieces of data. So if it's 10 pieces of data and if you start crossing out, you're actually going to have 5 and 6 in the middle. And if a 5 and 6 is in the middle, that means your medium is going to be 5 plus 6 divided by 2. And that is going to be at 5.5. That's by doing it by hand. Then if you do a Q1, okay, now Q1 is going to be split between all of them by quarters. So if you split, 5 and 6 is a split, and if you look at the left hand side, 4 will be the middle one, so Q1 will be 4. If you look at on the other side, which is your right hand, the upper quarter. So in this case, you are going to look at all the numbers 6, 7, 10, 17, and 28. 10 will be your middle one. So therefore, that's a Q3. So that's 10. Now, if you know how to do this on the calculator, you can also pick up the numbers from the calculator. Number 3. Describing the meaning of the results of Q1, Q2, and Q3. Now, from the previous discussion, you guys know that Q1 is at 25% and Q2 is at 50 and Q3 is at 75. So the explanation is approximately 25% of the observations lies in each of the following groups of the study times: less than 4 hours, 25%. Between 4 and 5.5 hours, 25%. Between 4.5 and 10 hours, that is another 25. And then greater than 10, another 25. So that is how you can describe them, and then see where you guys, how the quartiles explained. And the interquartile range. Well, interquartile range is between the Q3 and Q1. So therefore, is the numbers between 75% and the 25%. So in this case, is you can see it. You can understand what I'm talking about. Once we, if you look at it, the Q1 is going to be at 25, and Q2 is going to be at 50, and then Q3 it's at 75. So you are picking up the numbers between those two. So take the number from Q3 minus the number at Q1. That's all. The interquartile measurement is the spread of the middle 50% of the observation. Okay, so think about this. 75 minus 25 is the middle 50%. Now the next question is asking, use the answer example 1 to answer the following question. Calculate the IQR, and in this case the interquartile range. So let's go back up and look at some of the numbers and then see where are they. Okay, so here's example 1. Your Q3 is 10. Your Q1 is 4. So your interquartile is going to be 10 minus 4, which is middle 50% is 6. So most people, the middle 50% study about 6 hours. Make sure you write down 6 hours. You need to have the units. Then the next question is asking, calculate the range. Well, the range last time we put in order, just want to make sure you recheck. The biggest number is 28. The smallest number is 2. So, range, again, is the biggest number minus the smallest number, or the max minus the min. Or you can look at your calculator and they will tell you what's max and min. So let's write that down. The largest number is 28, so the range is equal to 28 minus 2 equals 26. So 26 hours is the range. Number 3. What do the IQR and the range mean in this situation? I'm going to write it down. You guys copy and we can talk about it. Number 3. What do the IQR and the range mean in this situation? Well, the IQR is small. That's interquartile range. It's 6 hours. And that suggests that the middle 50% have a very small spread. Okay, middle 50%. Now the next one, you have the range, and the range is large, 26 hours. That suggests maybe there's an outlier. That means somebody who really studied really hard, because 26 compared to 6 is a huge difference. So somebody studied way longer than most other people. So that's why it's an outlier. Remember, outlier is something that's really extreme data that you're not sure what's going on. Okay, so the next thing is really important. I put it in 3 little stars on both sides, and you guys have to fill it in. IQR is resistant to to outliers, and the range is sensitive to outliers. And what does that mean? Well, IQR means it doesn't react to outliers. Okay, that means the data does not change a lot. The range is, if you noticed, most of the 50% is right in the middle. We are not looking at the extreme, but the range is looking at the biggest, the smallest. So there's totally extreme case. IQR is in the middle. Who is the most commonly data probably is going to be located. So there is a huge difference on that. Because the extreme situation, the range is very sensitive to whatever the two extremes are. Please make sure you understand that. All the rest stuff too, okay? And jot down the notes. Five number summary, which is you guys hear me saying it over and over, is the lowest value, MIN on your calculator, Q1, median, MEDIAN or MED, I think that's in the calculator, Q3, or the highest value, max. So this is going to be min in your calculator, I believe, and this is going to be the max. So you have the 5 number summary on your calculators. Next thing we're going to talk about is box and whisker plots, okay, or box plot. That's what sometimes we call it. And that is a diagram that allows us to visualize the IQR, which is the middle 50%, and the range all together, and the diagram for 5 number summary. So we're going to put all those things together so you can see the comparison, where does the data is going to fall. So how do you construct a box plot? Example number 2, I'm going to show you how to construct one. So in this case, there's your 5 number summary. Smallest observation, 0. The Q1 is 15, Q2 is 45, Q3 is 90. Largest observation is 150. So in this case, you should get a little bar on the bottom. Okay, so that way you know where everything should fall. So since notability is really nice, we're going to start with 0. And I'm going to go by 10. Because if you go by any other numbers, it's going to be really crazy. We don't want to mark 150. Okay, and then if you go smaller than there's a 48, it's kind of hard to do. So I'm gonna pause the video and then mark it, and we come back to it. Put the smallest observation down. So smallest observation is 0. So we can put in a dot, and sometimes you can see it. That's a bar. So depends on the situation. You can do it that way, or you can do a bar. And I'm going to do a bar because sometimes my dots just does not come out right. So here is a bar. So a little tick mark right here. Okay, and then Q1 is at 15. So 15 is right here. I'm going to make a bar like this. Okay, because eventually we're going to connect them. Then what we're going to do is I'm going to do Q2. Q2 is a 48, so it's not quite 50. We're going to do Q2. And then we have Q3 is at 90. Those are longer bars. So your Q1, Q2, Q3 has longer bars. And then 150 is going to have a little small one. The two ends, the maximum gets the small bars. And the Q1, Q2, Q3 gets the big bars. And then you are going to just connect them like this. Make a body, kind of. And then extend it to the tail. And that is it. You just did the box and whiskers. Those two extensions that extend the line extended out to the little maximum is your whiskers. Now, we usually like to label them. So you want to label Q1 right here is 15. And then you have Q2 is at 48. And then you have Q3, that's going to be 90. And there's your minimum. That's at 0. And there's your maximum. And that's going to be at 150. And this thing right here is called the whiskers. And right here, this part called box. So there's your box and whiskers plot. Okay. Now, I also want you guys to think about this. This is most the data leaning towards the left. So therefore, the number that's maximum is 150. And so therefore, those number is going to get less and less. Imagine your histogram situation. Most of the data that clumps is actually on your left hand side, and then your tail is facing to the right. So in this case, you should be able to tell me this graph is skewed to the right. Example number 3. Example number 3, make sure you enter it in the calculator because this is too hard to figure out. So once you get it, you can pause it and come back and I'll show you the answers. Hi guys, so those are the numbers I have getting from the calculator. I hope you got the same numbers. If you don't, please let me know because then we can check on it. Okay. So based on those numbers, I'm gonna do a box plot. Now the problem is how do you decide what's the box plot number is going to be? My smallest is 111, so I think I'm gonna start with 100, and then we're gonna do maybe up to 500 or 550, so maybe I'll go with 50 in between is my gap. Okay, so then we kind of just see how that works out. So here is my box plot on the line. Okay, so I'm gonna start with 0, and then since over here I'm gonna have 500 or 450. Let's do 450 because that's the biggest number. And maybe I will just go by 50, 100, 150, 200, and then maybe 250, 300, 350, 400. Uh-oh, I think I need to make it a little bit bigger. So let's make it, erase that. Maybe I should just 450. Okay, probably my beginning is a little bit too small, too big. But anyway, so that's the basic look. All right, then I'm gonna say, okay, I'm gonna start with, actually you probably can shift it over and start with 50. You know, that's totally doable. So 111 is going to be between like right here, probably a little bit lower, small tick mark. And 166 is going to be a little bit more than 150. So here's 166. And then 209 is going to be definitely a little bit more than 2 right there. And then 314 is going to be more than 300 right there. And then 439 is going to be a little bit more than 425, so it's going to be a little bit more halfway than between. So now I'm going to connect them. There's my box, and there's my whiskers. And make sure you label them. This is your min, and that's, you want to put down 111, that's fine. You can put a top or bottom, it's up to you. And this is Q1, and that's going to be 166.5. And then you have Q2 right here, and that's 209. And you have Q3, and that's 314.5. And then this is 439. And I think I got a little bit too long here, so let's redraw that. Okay, and that is your box plot. Any question, please let me know. Anything that's not clear. Please try example number for yourself, okay? And then come back and check the answer with me. But let me read you the question. The waiting time in minutes before placing an order was recorded for a random sample of 10 people from a particular fast food restaurant. Construct a box plot for the following set of data. List 5-number summary. Please use your calculator and construct a box plot. Okay, come back and see, do you guys get the right answer? Please check your answers. I hope your answer is similar. If you do the tick mark by one at a time, that's totally okay. I just want to save a little work. I would think going by 5 will be a little bit tough just because we have 2 and the 4 and the 5.5, and that might get a little bit crowded. So I went by 2. Okay. I hope if you have any question, please let me know. That will be concluding the box plot. Thank you.